I don't know about the rest of y'all, but I'm still hungover. I'm old, Mick, okay? So I stay hungover longer.
I saw that text, it's like, what was it, 7:38? I'm like, I felt like I was dying. I think someone is it might be a while until you get response.
Alrighty then. AV ready? Awesome. So now it'll be on the internet and I'll be famous. Alrighty. If you're here for There's No Place Like Dual Homed, you're in the right talk. If not, please stay. I don't know. So, as the title says, my talk's about There's No Place Like Dual Homed. Start out with who is David Young Jr. I've worked in the IT industry for, 23 years. Last in 10 in security. I've worked healthcare, government, financial, utility, all those fun places. I'm a very amateur lock picker. I'm an avid gamer, PC Master Race, console sucks. I like nerdcore rap, dubstep. I'm into anime, not the tentacle stuff, and Gundam models. That's me, picture of my wife. I just pointed to Era to make sure you could understand that's me. I'm not the other one. Great, I got hecklers in the front. It's going to be wonderful. So the talking points for this is, of course, what's a dual home system? Why would we use a dual home system? A little out of order. The demo is actually at the end. I have a video demo of me using this in order to actually go, we'll say, 2 subnets deep into an environment to get the goodies, as they say. And that's what the but wait, there's more. And discuss a little bit of mitigations on your network, how to prevent this, and some other things around that. And then, of course, take any questions you have. So what is a dual home system? Now, of course, the standard definition is a system that has more than one network interface. Now, generally, this was used especially on network devices and servers, so that if you had a failure in one network interface, the second one could pick up or take over. Sometimes in the network devices, it's shotgunning. So if you want to do increase speed across a network, if you have 2 sources coming in like that. But on a Windows system, what's interesting is you can assign, of course, one IP subnet to one interface and a second IP subnet to another interface. And it kind of almost acts like, we'll say, a makeshift router or switch. Here's a little graphic I found. It's the best one, because the one I drew in Paint was really horrible, so I felt this was a little better. Back in the day, way back in the day, I actually did something similar to this with my internet cable connection using Black Ice Defender and internet connection sharing. I had a 386 compact computer and cable connection coming in one side and using internet connection sharing to share out to all my devices on my home network, which is about a whole 2 devices at that time. So why would somebody do this? Now, this was also a question I kind of asked myself when I ran into this. Now, previously, as I mentioned in the definition of a dual homed, a lot of it was for redundancy, was the original thought. You know, one interface goes down, that web server can't be offline. So we've got another interface there, and through routing and either round robin or bandwidth sharing, you can keep those systems up and alive. Like I said, on a Windows system, though, people found out you can create a second subnet using this. So now you can have a lab, a dev, a whole different network environment with minimal costs. I mean, nowadays, what's a network card? A couple bucks at best. So they don't have to spend all this money to set up this whole big environment. They can just throw in another network card, say, okay, these are all going to be a different subnet, and everything's hooked in behind that. And as I say on the bottom, it's one of the big issues is it makes it easier for the users to bypass complicated policies and procedures, and the whole budgeting issue too. I need a lab. We don't have the budget for that. I got $10, we can fix that. So kind of on discovering a dual home system is kind of obvious, but not. If you've ever been on a system and you do an IP config, you all of a sudden got Ethernet 0 and Ethernet 1 and 2 different IP addresses on there. And again, in the scenario I was involved in, when I found this, I'm like, well, again, the question is why are they doing this? And what's behind the magic curtain? Of course, being a hacker, and when hackers get curious, it kind of gets dangerous. So now you've compromised a system that's dual homed. Is there anything behind it? There are various methods. I know a lot of the documentation out there say, use it as a pivot. We're going to pivot through it. That works. I found some of the tools are really finicky about working through a pivot or a proxy, if you set up the proxy chains. They will work. I've just had some weird, inconsistencies with them. Now you can use it as a pivot to do some maybe initial ping sweeps and find if there's more behind it. Also too, within a Windows system, you can just do an ARP-A. And it'll tell you everybody that it's talked to. And then you can kind of find some sources behind there that it's talked to. And that's kind of in the bottom half of the screenshot, you can see the 10.10.50.10. Now the original IP is a 192.168.20.5 on the device. But you can see it's talked to a 10.10.50.10, so you're like, oh, well, there's something out there. I want to believe. So how can you get to these dual home systems? Like I said, you could use the proxy pivot. It can be slow. There's some issues. Nmap does some weird things too when you use proxy chains. So doing some research now, fortunately, have a license for Cobalt Strike. I don't know if you're familiar with Cobalt Strike. Raphael Mudge is his name. It's a wonderful tool, especially if you have a team for collaborating. You can all see the targets. You can see who's on what and using different tools. And no, this is not a paid sponsorship. But so essentially, on one of his blogs, he talked about he had named SMB named pipes. And with that, you can use it to tunnel through to other targets. So then now we're going to get into what is an SMB named pipe. So named pipes, as it says there, and I'm going to try not to read too much, are similar to open TCP ports, where the client can connect to the server listed on a given port. A lot of times it's based on SMB, and you set up a port on the machine you've already compromised, and you say, hey, let's talk through that via SMB to the other side. And what's wonderful about Windows is Windows loves SMB. And a lot of the firewalls you're running to, they're going to block all those odd command and control channels that you got out there. So I'm going to do HTTP. Well, we don't allow that traffic. HTTPS. Well, we don't allow that traffic. There's no need for that traffic to be going in between those areas. It shouldn't be happening. And this is only if you're dealing with a firewall. And even on the Windows firewall, you can kind of run into those issues. Also, setting up an SMB named pipe raises a lot less flags with the blue teams. I mean, I'm not sure how many blue teams out there can say, looking at all their logs, that's odd SMB traffic. There's a lot of that going on out there if you have Windows in the environment. Makes it very difficult. Now, obviously, if you're in an area or a zone where a lot of SMB traffic doesn't happen, like your web DMZ and all they know is web traffic's supposed to be there, that may raise some flags. But if you're on a normal network compromising a system, it's very helpful to hide within the chatter, as they say. And as I said, a lot of the networks, they may block other ports that you try to use, but SMB, if it's Windows, and they want Windows to talk to Windows, that will usually always be open, unfortunately. Nope. A little out of order, and I apologize. So, but wait, there's more, as I said. So digging around, I was able to compromise the system. We're not really going to talk about that, Eternal Blue. Once got on that system, found it was dual homed, was able to hop through it, poke around in this additional subnet, found another device that was yet dual homed again. And I went, well, I wonder if this would work going even deeper. And it did. I was able to hop essentially 3 subnets deep in order to get all the goodies. Now, the unfortunate part for them was that there was a challenge thrown down. You'll never find our QA dev environment. You'll never get in there. Oh, give me a little bit. So that was kind of interesting, was being able to use Cobalt Strike to essentially hop through 3 subnets through SMB name pipe in order to get into those networks that they said we'd never be able to find or get into. Essentially, this is what it looks like when you do the visual view in Cobalt Strike. The user A, or the initial box there, the PC box A, was the initial compromise. That's the box we got on. We find that that one's dual homed. So we set up the SMB named pipe, and we were able to get on PC box B. And now, of course, after user A, we elevated the system. When we PS exec across through SMB, we get a system account on PC box B. And then from that one, that is dual homed, we're able to set up an SMB name pipe on that one and hop even further in to what I'm calling PC box C. And then once you get on C, you have full control and interactive on C, but you're not directly going from the attacker box all the way out there like you see in some diagrams when people do this. You're actually hopping through 2 other boxes to get there. Did I duplicate slides? I think I did. I apologize for that. So I do have a demo video of me setting this up. We'll go back on that. Just a sec here. And we'll kind of talk through the video a little bit. Is it going to let me? Huh? I broke it. Did I lose video because I switched?
Yes, we don't have video.
All dimmer strikes again.
Maybe turn it off and turn it back on again.
Thank you. You're all so helpful. There we go. I turned it off and on again. So right now, before I start the video, what has happened is, at the very top is the initial compromise of PC box A. And then from there, I made sure that I did a Git system. I made sure that I was elevated before I moved on from PC box A, because it's always nicer to work as a system level account than a standard user. So through ARP-A, I already discovered the other IP, as I was saying, the 10.10.50.10. So I set it up as a target, and then I PS exec across to it using the name pipe that I had set up on PC box A. Now, unfortunately, I didn't show that, but I will show that in a second. Now, as you can see, stop that. I was able to go from PC box A via the SMB named pipe listener in Cobalt Strike to PC box B. Now, I'm not sure if anybody's familiar with that. Cobalt Strike has a lot of nice built-in tools. From there, you're able to dump hashes, run Mimikatz, get all the goodies and user logins. Now, another failure on this part was password and account reuse. They had same accounts on one system, that they were using on these internal networks across the board. And we were able to take advantage of that also. So then, what's interesting too is if you look at the interfaces on PC Box A or PC Box B, the external gives one IP, the internal gives a different IP, and this was also a queue, but fortunately because we were using Cobalt Strike, gave me a queue as I'm on another dual home system. All right, so what we're going to do from here, I said, well, there must be something on that 172.16.50 range. So I start interacting with it. Well, first thing you always do is dump the hashes and run Mimikatz, because you want all the things from there. Drink all the booze. And as you can see, it's all the hashes we've got at that point in time. And if you're really fortunate, hopefully they haven't applied the WDigest pass and you get some plain text ones. That makes your life a lot easier from there. So then I'm just going to show, okay, well, let me run an IP config, normal reconnaissance. I would do a lot more than that, but for this demo, I'm just showing, okay, I see the second interface with an IP on there. All right, well, how does this talk to anything? Well, let's run ARP-A. Why, yes, it has. There's a 172.16.50.10. Now, admittedly, in the actual use case where this happened, that ARP table was huge. There were many other devices it had talked to. So I'll go, okay, so then we set up, within Cobalt Strike, we set that 172.16.50.10 as a target, as I'm highlighting here. Copy paste, because copy paste for the win. So we set it up as a target. Now, I don't know what OS it is, so I set them up as unknown. Once you get connected in, Cobalt Strike is smart enough to pull that system information, and it'll update this table. Now, this is where I'm getting ready to PS exec straight across. But I forgot, I need to set up the listener. So when doing the SMB named pipe, let's just get a little bit further ahead. And, oh yeah, you could see me mess up here. I forgot the IP. So you set up a listener, but you set it up on the second interface that you want to hop through further into the network. So, and then I go to put in the IP here, and of course, while recording a demo, I forgot the IP I needed to put in. So on System Box B, or PC Box B, as I'm calling it, I set up an SMB named pipe listener on the 172.16.50.5, and that was the second interface in that box. And you just use SMB named pipe, pick the port of your choice, save that. And then, once you have that listener set up, I'm going to say, okay, now I want a PS exec to that third subnet. Now, like I said, for brevity, there's account reuse and that here, but unfortunately in the real world, you will find that all over the place. People will use the same passwords everywhere. Oh, I'm on StarNix box. What's an AD account? It can't be in there. Oh yeah, it's the same thing. Makes you sad, makes the clowns cry. So then you send the listener, you choose the listener where it says it's going box A to box C, and I choose a session. This is Cobalt Strike, and I just choose the session on that box, and I launch, and it opens up a SMB named pipe, connects through to admin $, uploads a malicious payload, and Bob's your uncle. As you can see, 1, 2, 3, the fourth IP line that popped up there is yet another connection through a different subnet. So I've gone from 192.168 to 10.10 to 172.16. And then from here, directly from this interface with Cobalt Strike, I can start. Cobalt Strike has an interesting thing. You have to tell it to sleep a certain amount of times, or else it'll take a whole minute to recycle and call back home. That is another thing with this technique. It is SMB, so you can kind of be quiet, you can be as noisy as you want. So setting it to sleep 0, it just looks like SMB chatter going back and forth. And of course, then you dump the hashes and run the Mimikatz. And then I'm just showing with an IP config, this is the final system, and it only has one card. I thought it'd be kind of neat to go even further, but. And if you change the view, and this is the screenshot that I showed earlier, you can see here, it's showing from the attacker, which is the wonderful flaming firewall there. And the bottom one is the initial connection, and then I privesc on the top one, and then use an SMB name pipe, just hop right through, all the way through. And you have full control then, full session control.
Woo.
So here's where it gets interesting. So what if we don't have Cobalt Strike? Well, according to Metasploit, they do have an SMB name pipe component. This is where I kind of hope someone can help me with this. I had a Twitter conversation with the guy who wrote it. He says it works, it should work. I could not get it to work to save my life in my lab environment. I'm able to go from the initial compromised one in, and when I try to set it up to go this too deep, I could not get it to work. And I really do hope if somebody else decides to tinker with this and take a look at it and figures it out, let me know how you get it working. I will admit, even with the Cobalt Strike, we were reading Raphael's blog. One of my coworkers, he worked on it for, I know he spent several hours looking at it, and he was like, all right, I'm out. He tapped out. And I picked it up and took over, and I spent a pretty good half a day trying to figure it out. The tool is awesome. Raphael is awesome, but some of his blogs are, I would call them like stereo instructions. He knows the tool inside and out, so he knows when he writes it, he kind of comes across that way, so it's not that step by step. Was able to figure it out, and also the very bottom one was someone that was blogging about on the SMB name pipe pivoting interpreter. And like I said, I gave it several whacks, several tries, and I'm still tinkering with it and hoping to get it fixed. So, cool, we found out how to bypass all this. So what do we talk about mitigating this? Well, the biggest one is, let's look at your policies and procedures. How many hoops are you making somebody jump through that says, hey, I just want a dev environment. I want, 3 or 4 boxes where I can store this information that I'm working on or prepping for deployment. How hard is it for them to navigate that system to get those set up? And unfortunately, that's what we're hearing is a lot of the reasoning behind this. It takes too much time, IT takes forever, and then there's budgeting. I can just go down to Best Buy and buy a network card. So let's say we do get the proper equipment though. Proper network segmentation, firewalls and stuff. Even consider two-factor authentication if the information is that sensitive. My big thing there, I'm saying too, if it's truly sensitive information, it should be a true air gap system. And I know a lot of people out there, have run into these air gap systems, but they're all plugged in the same switch. That's not air gapped, I'm sorry. That's segmentation, yes, but not air gapped. So, and a little bit of user education. The big one I have there is account and password reuse. If you have several accounts, don't reuse that same password in that across several systems. Because once I compromise one, you think, okay, well, yeah, you compromise one user. Yeah, but he can log in all over these other places. And I was able to crawl all around your network because of that. Also talk to them about setting up what I call a homebrew network. I understand, I know the system's frustrating, but you also see what we were able to do just by walking in and hopping through systems. We were able to get to this data that you said we couldn't get to. Another thing would be, and this is a sore point, hardware inventory spreadsheets. Any type of system where you can kind of inventory your hardware, and if you notice, hey, our normal desktops only come with the one network interface. Why do I have a list of them now that have 2 network interfaces? What is up with that? So that's one of those big things, and I know that's a struggle a lot of companies have with is the hardware inventory. So are there any questions? And if anybody would like to discuss more in detail what I did, I'm more than open to conversations afterwards, especially with a beer. Yes, sir.
So you firmed us down the first box, and then you did the named pipe to get to the second. Why does that system connection work on that?
Okay, well, it is an SMB, so there are some other mitigations you can, like not allowing remote administration and remote access to block the SMB. The reason it worked in that situation was those controls were not in place, and also they were using a local administrator account across all of those devices.
So in your system, you're a local admin.
I was local admin. Well, they were actually using it in my, it was local admin in my environment, but in the true environment, it was a local account that they use, an AD account that they use across the board.
So same path.
Same password. And that's the password reuse that I was talking about. Anybody else? Thanks. Here's my contact information. Sign me up for all the mailing lists you want. I enjoy it. I know, I put it out there, so. Well, thank you very much. I want to thank DerbyCon. Have a good time.